Hey everybody, so I'm just going to work through a series parallel question. There's just a few people that have asked if I would work my way through this. So I'm going to do this in a couple of different videos just so we can kind of break this up so it's not 15 minutes long. And if I have a source voltage of 120 volts, the first thing I'm actually going to do is take us through the process of how to calculate resistance total, and then I can get current, and then I can get voltage. So I'll do them in a few different videos just so it's not one big lengthy one. So this one's going to be about calculating my resistance total. So the first thing I have to do when I'm calculating RT is I have to look at this circuit and I have to try to identify, is there something directly in parallel with one another? Is there something directly in series? The idea is to build a model that replicates an equivalent circuit is what we're doing. We're breaking this down to create an equivalent circuit to analyze, make it a little bit simpler for us. So when I first start out, I'm looking at this circuit and I have to see, is anything directly in series? That means there's no nodes, there's no nothing between the two components, or is there anything that are directly in parallel, something that's sharing the same voltage. So when I do that, the only one that's directly in series or parallel, and it can only be one or the other, is these two devices right here. They are sharing the same voltage. So I add those two components because they're in parallel, I just use my parallel rule. So when I want to when I come up with the equivalent of really what R1 and R2 in parallel are, I have to add them inversely. So that's 1 over R1 plus 1 over R2. Okay, so our combination of 1 and 2 in parallel is going to be 1 over 180 plus 1 over 120, all to the inverse, and we end up with 72 ohms. So now what I have is, what I'm going to do is draw an equivalent circuit. It's not going to be the same because we've just combined those two in parallel. So my new circuit is going to look like, I'm going to have my negative terminal, it's going to come, and I'm going to have my new R1 and 2 that I just combined, and it's 72 ohms. Okay, and now if you want, you can leave that little node there just to show that's where it was. R4 is 18 ohms. So we've combined those two together. And then on the other side, you know what, I have to move where I wrote R4, got to draw a little resistor here. So that is R4, which is 18 ohms. And in parallel with these whole thing, if you'll notice where that we didn't move or shift R, I'm going to have to redraw that. I keep forgetting to draw the resistors in. R3 is still 72 ohms. And then I have my R5, which is 200 ohms. And I continue on from here. I analyze again, is there anything directly in series? Is there anything directly in parallel? So I can see that the combination of 1, 2 is now in series with 18. So because they're in series with one another, and it's the only, I don't want to tackle R3 yet because it's not directly in parallel with anything, not quite yet. So we're going to create an equivalent. So I'm going to add my R1 and R2, and it's going to be R1, R2, R4 is essentially what I'm going to come up with now. that's going to be adding R1 and R2, the new equivalent of 72 ohms, and I'm going to just add it together with R4 because they're directly in series with one another. The current coming through the combination of 1 and 2 is identical to what is traveling through 4. So this is 72 ohms plus 18 ohms, and we get 90 ohms for our equivalent. So now what I'm going to do is I'm just going to scroll down, if it will let me. Here we go. And I have to come up with my equivalent circuit now. So just to make sure that I get this right, I'm going to probably do this just scroll up and down just to check. So this should be my R1, 2, and 4 equivalent, which is 90 ohms. Directly in parallel is R3, which is 72 ohms. And then I have R5, which was 200 ohms. I just want to double check that that's correct. Yep, so we added 1, 2, and 4 in series. Directly in parallel is R3 of 72 ohms. And I have R5 is 200 ohms on the end. Yep, okay, good. Just so we're following through with the right procedure. Now I just do another analysis. And I look, okay, what is directly in series? What's directly in parallel? So my 90 ohm equivalent, when I come up with R1, 2, 3, and 4 now, it's in parallel, so I'm going to add it inversely with my equivalent R1, 2, 4, added inversely with R3, because they're directly in parallel with one another. They're sharing the same voltage. So I'm going to be 1 over 90 plus 1 over 72. So when I add those together inversely, 90 inversely with 72 inversely, all to the inverse, I get an equivalent of 40 ohms. Yep, so last step, I'll just draw this out. You might see how this is going to look already, but I'm going to draw it out anyways, so that we see how we're going to finalize. R5 is 200 ohms. R1 to 4 is an equivalent of 40 ohms. I don't want you to think 1 minus 4. 1 to 4 is an equivalent. Is this the exact same circuit? No. We're building an equivalent circuit. So now to get the final, they're directly in series. So my R total is just going to be R1 to 4 plus R5, which is 40 ohms plus 200 ohms. And I get an R equivalent of 240 ohms. So that's the process. You're just constantly looking for what's directly in series or what's directly in parallel. And every once in a while you can kind of combine, because you've got two that are in series, two different portions that are in series. You can do it in one step. But what you're creating is you're slowly going through this and creating an equivalent model for an analyzing what the combination of components would be with their oppositions either added in parallel or added in series, depending on how they're connected. So I'm just going to leave this one at resistance total. Next video is going to be about how do I go through the process now and identify current and voltage of each component. So I hope this has helped. Thanks for tuning in. We'll see you in the next one.